The aircraft arrived at Rechlin, Lerche, the Luftwaffe's central test facility 90 kilometers north of Berlin, sometime in the late summer of 1943. The exact date is contested. Luftwaffe test records for that period survive in fragments, but the airframe was a Republic P-47C, or early D-model Thunderbolt, recovered largely intact after a forced landing in occupied Western Europe. The Erprobungsstelle Rechlin had been the German Air Force's evaluation center since 1925, and by the third year of the war, its hangars held a small museum of captured Allied hardware. A Spitfire Mark V flown in from a Channel Coast crash site, a Hawker Typhoon, fragments of a B-17F. The Thunderbolt was something else. The mechanics who rolled it into the assessment hangar were looking at an airframe that weighed, empty, somewhere around 10,000 pounds, nearly twice the empty weight of a Messerschmitt Bf-109G. Hans-Werner Lerche, a test pilot at Rechlin who would later evaluate captured Soviet and American aircraft, described the early reaction in post-war testimony. The German technicians could not initially understand what the airplane was for. It looked, one of them reportedly said, like a fighter built by people who had confused fighters with bombers. The fuselage was deep and barrel-shaped. The cowling housed a Pratt & Whitney R2800 double wasp, 18 cylinders in 2 rows, displacing 2,804 cubic inches. The supercharger ducting ran the length of the belly to a General Electric turbosupercharger mounted aft of the cockpit. Drive shafts, intercoolers, and exhaust piping filled the lower fuselage in a layout the Germans had no production equivalent for. By comparison, the BMW 801 radial in their Focke-Wulf 190, the closest aerodynamic cousin to the Thunderbolt in the Luftwaffe inventory, displaced 2,560 cubic inches and produced roughly 1,700 horsepower at sea level. The R2800 at military power produced 2,000. With water injection, briefly, more. The mechanics began stripping panels. What they found inside was a study in American manufacturing philosophy, and it disturbed them. Alexander Kartveli, the Georgian-born chief engineer at Republic Aviation in Farmingdale, Long Island, had designed the P-47 around the turbosupercharger first and built the airframe to wrap it. The result, by 1943 production standards, was the heaviest single-engine fighter flying. A combat-loaded P-47D weighed roughly 13,500 pounds. The Bf-109G6 weighed approximately 7,500 pounds combat-loaded. The FW-190A6 weighed approximately 9,700. Rechlin technicians measured wing area at 300 square feet and recorded a wing loading that German doctrine considered unacceptable for a frontline fighter. The armament was 8.50 caliber Browning M2 machine guns, 4 in each wing, with 267 to 425 rounds per gun, depending on the loadout, a total weight of guns and ammunition exceeding that of some twin-engine German aircraft's entire armament suite. The Luftwaffe's standard fighter cannon, the MG-151/2-0, fired a 20mm round at roughly 700 rounds per minute. 8 Brownings together threw 6,400 to 6,800 rounds per minute downrange. The mechanics opened the wing panels and found the gun bays accessible, the ammunition feed belts laid out in long curving troughs. The entire arrangement designed for ground crew speed. Spent cartridge ejection chutes were cut clean into the wing's lower skin. Lerche later wrote that the build quality of the wing structure was, and the word he used was erstaunlich, astonishing. Aluminum gauges thicker than equivalent German aircraft. Rivet patterns denser. The Thunderbolt was not built like a sports car. It was built like a bridge. The cockpit told them something else. When the Rechlin mechanics climbed into it, they found a workspace that was, by their standards, almost decadent. The pilot sat high under a framed canopy. The bubble canopy of the P-47D-25 had not yet reached the assessment hangar, with armor plate behind the seat, armor glass forward, and an instrument panel laid out in what German pilots evaluating captured American aircraft consistently described as a logical, uncluttered pattern. The control column was conventional. The throttle quadrant, mixture, propeller pitch, and turbosupercharger control were grouped on the left console in a way that allowed single-handed power management. Heinrich Beauvais, Rechlin's chief test pilot, would later remark that American cockpit ergonomics had moved ahead of German practice by a noticeable margin. There was a relief tube. There was a cup holder. The radio was an SCR 274-N 4-channel VHF set, and the mechanics noted that the channel selection was preset by ground crew rather than fumbled in flight. The seat was adjustable in flight, the rudder pedals adjusted on the ground. One Luftwaffe technician, examining the hydraulic system, found that the landing gear, flaps, and cowl flaps were all powered, requiring almost no muscular effort from the pilot. The Bf-109's landing gear retraction handle was, by contrast, a hand crank that German pilots had been complaining about since 1937. The mechanics pulled the engine cowling, 18 cylinders, each one the size of a small barrel, arranged in 2 rings. The forged steel crankshaft alone weighed more than the entire power plant of a Böker trainer. They began measuring tolerances and comparing them to what they could produce at the Daimler-Benz works in Stuttgart. The comparison was not favorable to Germany. By late 1943, the Reich's aero-engine industry was being slowly strangled by raw material shortages, particularly in high-grade alloy steels and the nickel needed for turbocharger turbine wheels. The R2800 used materials Germany was struggling to obtain in quantity. The turbosupercharger's turbine wheel, manufactured by General Electric in Lynn, Massachusetts, was a precision casting in a heat-resistant alloy that operated at exhaust gas temperatures above 1,500 degrees Fahrenheit. Germany had pursued exhaust-driven turbosupercharging through the war, but had never managed to put a reliable unit into mass production. The mechanics at Rechlin, examining the GE unit mounted in the Thunderbolt's belly, were looking at a piece of hardware their own industry had been unable to replicate. The ductwork that carried exhaust from the engine, aft beneath the cockpit floor, into the turbine, and then routed the compressed air forward through the intercooler and back to the carburetor was 30 feet of carefully insulated, precisely machined plumbing. It was the reason the Thunderbolt could fight at 30,000 feet and above with no power loss. A Bf-109G at 30,000 feet was a tired airplane. A P-47 at 30,000 feet was just getting started. Hans Fey, a Luftwaffe pilot who flew captured Allied aircraft for evaluation, later told American interrogators that the Thunderbolt's high-altitude performance had been a strategic surprise. The Germans had assumed, into 1942, that the United States could not produce a single-engine fighter capable of operating effectively above the bomber stream's cruising altitude. The captured airframe at Rechlin was proof they had been wrong. The next question was what it cost to build. That question the Germans could only estimate. The Republic aviation plant at Farmingdale, with a second line at Evansville, Indiana, would deliver 15,683 Thunderbolts by war's end, a production figure that approached the total combined output of the Bf-109 and FW-190. Republic's Farmingdale workforce, drawn from Long Island defense labor pools, exceeded 23,000 by 1944, including a substantial number of women on the assembly lines after the Selective Service had pulled most able-bodied men into uniform. The mechanics at Rechlin could not see this. What they could see was the evidence of mass production in the airframe itself. Standardized fasteners, interchangeable subassemblies, machined parts that fit without filing. A Luftwaffe maintenance officer who examined the captured P-47 noted that every panel had been stamped with a part number traceable to a specific subcontractor. The engine cowling carried a Pratt & Whitney serial. The turbosupercharger carried a General Electric serial. The propeller, a Curtiss Electric 4-blade unit, 12 feet in diameter, carried a Curtiss-Wright serial. The radio carried a Western Electric serial. This was the American aircraft industry as the Luftwaffe encountered it on the workbench. Not one factory, but a continent of factories, each making one thing and making it well, with the final assembly at Farmingdale acting as the meeting point of a supply chain that ran from copper mines in Montana to rubber plantations in liberated portions of the Pacific. General Hap Arnold, commanding the Army Air Forces from his office in the Munitions Building in Washington, had been pushing this model since 1941. Production was strategy. Every Thunderbolt that rolled off the Farmingdale line was a piece of strategy made physical. The Rechlin mechanics could measure the strategy in the rivet patterns. There were criticisms, and the Luftwaffe evaluators recorded them carefully. The Thunderbolt was heavy. Its initial climb rate, even with the turbosupercharger, was inferior to the Bf-109G below 15,000 feet. Its roll rate at low speed was acceptable but unremarkable. The early Razorback canopy restricted visibility to the rear, a complaint American pilots had been making since the first combat missions over France in April 1943, when the 4th Fighter Group at Debden flew the type into action. Range, before the introduction of the 108-gallon belly tank and later the underwing combat tanks, was limited. A P-47 launching from Bodney or Halesworth in East Anglia could reach the German border and return, but not Berlin. This was a known weakness, and the 8th Air Force Fighter Command under General William Kepner had been pressing North American Aviation's P-51 Mustang into the long-range escort role partly for that reason. The Rechlin assessment, what survives of it, was therefore double-edged. The Thunderbolt was an extraordinary piece of engineering. It was also, in the Luftwaffe's view, an airplane that played to American industrial strengths rather than to the tactical demands of European air combat as the Germans understood them. The Reich could not build something like it. The Reich also did not believe, in late 1943, that it needed to. The Bf-109 in its later G and K variants, and the FW-190A and the FW-190D and the TA-152, still on the drawing board at Focke-Wulf, were considered adequate. The Rechlin mechanics finished their measurements. The report went up the chain to General Feldmarschall Erhard Milch's office. Milch read it. Production figures for Bf-109 airframes in November 1943 were 725 units. Republic Aviation delivered 663 Thunderbolts that same month, and the United States was also building Mustangs, Lightnings, Corsairs, Hellcats, and Wildcats. By the time the captured Thunderbolt at Rechlin had been fully stripped, measured, and photographed, the air war it had been built to fight was already turning. On October 14, 1943, the 8th Air Force lost 60 B-17s over Schweinfurt, the second raid on the ball-bearing works, and the loss was traceable in part to the inadequate range of escort fighters, the very weakness the Luftwaffe had just confirmed. The American response was not to redesign the P-47. The American response was to build more of them, faster, and to put longer-range tanks under their wings, and to push the P-51 Mustang into service alongside, and to keep both production lines running at full capacity through 1944 and into 1945. The 56th Fighter Group under Colonel Hubert Zemke, flying P-47s out of Halesworth and later Boxted, would finish the war with 665 enemy aircraft destroyed, the highest air-to-air score of any 8th Air Force fighter group. Francis Gabreski, a Polish-American pilot from Oil City, Pennsylvania, would score 28 confirmed aerial victories in the Thunderbolt before going down on a strafing run in July 1944. Robert S. Johnson from Lawton, Oklahoma, would finish with 27. The airplane that puzzled the Luftwaffe mechanics at Rechlin in the summer of 1943, too heavy, too complicated, too expensive, built like a bridge, was, by 1944, doing exactly what Kartveli had designed it to do. It was loitering at 30,000 feet over Germany with 8.50 caliber Brownings and a pilot who could see, hear, and fight. The Rechlin file was filed. The war went on. Hans-Werner Lerche asked decades later what he had thought of the P-47 when he first saw it stripped down on the Rechlin floor, said that the airplane had told him something he did not want to know. He had seen, he said, what the war was going to look like.